Memory location. Memory location of the computer system is divided into small parts called locations. Each location has a unique address. Location is further subdivided into bits. Different computer systems have a different location size varying from 8 to 64 bits. Computer memory. Bit. Bit stands for one binary digit which is either 0 or 1. Byte. Number of consecutive bits combines to make a byte. The most commonly used combination is of 8 bits. Size of main memory is given in kilobytes, KB, megabytes, MB, and gigabytes, GB. Primary storage or internal memory or main memory. The main memory, also called random access memory (RAM), is the work area of the computer system. It stores program instructions or part of data for immediate needs. The storage capacity of RAM is limited. A typical modern computer system can have a RAM size of 32 MB or 64 MB or greater up to 8 GB or more. It is volatile memory of the computer system, and when the power goes, the contents stored in RAM are lost. RAM can be classified as DRAM, dynamic RAM, or SRAM, static RAM. Static RAM is random access memory that remains data bits in its memory as long as power is being supplied, unlike dynamic RAM, which stores bits in cells consisting of a capacitor and a transistor. SRAM does not have to be periodically refreshed. Static RAM provides faster access to data and is more expensive than DRAM. SRAM is used for a computer's cache memory and as a part of the random access memory digital to analog converter on a video card. DRAM. Dynamic RAM. Dynamic random access memory is the most common kind of random access memory for personal computers and workstations. The network of electrically charged points in which a computer stores quickly accessible data in the form of zeros and ones is called memory. Random access means that the PC processor can access any part of the memory directly rather than having to proceed sequentially from some starting place. DRAM is dynamic in that, unlike static RAM, it needs to have its storage cells refreshed or given a new electronic charge every few milliseconds. Secondary storage. The secondary storage devices are used to store programs and data on a permanent basis. Their storage capacity is much higher compared to the main memory of the computer system. Secondary storage devices accept data or program instructions from the processor, retain them, and then write them back to the processor as and when needed. The examples of secondary storage devices are hard disk, magnetic tapes, and pen drives, etc. Hard disk. These are specific kind of storage devices that cannot be removed and are fixed inside the computer system. That is why these are also called as fixed disks and store programs permanently. The storage capacities of the disks that are used these days are having gigabytes of storage, and these are faster in comparison to floppy disks. Magnetic tape. This is also a magnetic media which stores data sequentially in them. Though they provide unlimited storage capacity, they suffer from a very serious problem. Since the data stored in them is sequential in nature, retrieval of data takes a very long time. These are used for archival backup storage. CD-ROM. Compact disc. Read-only memory optical disks have a very large storage density and the access time is relatively low. Digital versatile disk. Digital versatile disk is a genre of optical disks. with same overall dimension of CDs but much higher capacity. These can store at least 7 times more data than CD-ROM. Static memory and memory sticks, also commonly known as pen drive or jump drive or flash drive. Static memory devices use memory chips to store information. This information is retained even power is turned off. They connect to a USB port on the computer system and offer capacities of 128 MB or more. Due to their size and shape, these devices are known as USB memory keys or flash drives and have widely replaced floppy disks for transportation of files between systems. Many portable and handheld devices rely entirely on static memory for storage. Semiconductor memory. These days, internal memory consists of extremely small bit storage circuits, flip-flops, etched on a silicon chip. All the electronic elements to store a bit are placed in such a small area of the chip that a single chip can store millions of bits. The individual chips are arranged in groups to form a memory module. Random access memory, RAM. Any information can be read from and written into a RAM. It is a read and write memory. It is a volatile memory, that is, its contents are lost if the power supply is interrupted or turned off. The main memory of the computer system is RAM. Read-only memory, ROM. It is thus completely non-volatile. ROM is permanently programmed with information during manufacture by implementing the appropriate pattern of two state values. It cannot be changed subsequently by a normal write operation. It is mainly used to hold those programs which are required permanently. Cache memory. It is a small capacity, high-speed memory used to make processing faster. The main memory can process information very fast, but it takes much longer to transfer data to and from the input and output devices. The cache memory compensates for this mismatch in operating speeds. It holds those parts of data and the active program which are most frequently used. Thus, the performance rate of the CPU improves.